I'm Ben Johnson, and it is go time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. We are back for episode number 15 of Go Time. On the show today, we have myself, Eric St. Martin. Brian Kittleson is also here.
Hello.
And Carlicia Campos.
Hi.
And then our special guest today is pretty well known in the industry and has quite a number of interesting projects and articles that have been out. Please welcome Ben Johnson.
Hey there. Thanks for having me.
I'm crazy excited about this, Eric. I got to tell you.
I know, me too.
Ben is a staple in the Go community, the smartest man alive, probably the nicest. Maybe him and Matt Holt might be in a tie for the nicest guys alive. So this is going to be an epic show.
Yeah, I mean,
seriously.
One of the things I remember, this is a number of years ago, was just kind of like, I'm going to implement Raft.
It's like, that wasn't necessarily a good idea, though.
The learning lesson of it, right?
Yeah, it's definitely a learning experience.
And Brian, I'll tell you, I have the addiction to databases too. So
they're fun. They're really fun.
So I think first, because it's more newer content, one of the first things I'd like to talk about is like your new series of posts, your walkthroughs.
Oh, sure.
Holy crap. Wow.
Yeah.
Wow.
Yeah. No, it's been a really cool experience. I thought I was just going to kind of go through and explain some stuff. And I use the standard library quite a bit. A lot of people give me a hard time just because I tend to not use third-party libraries, maybe when I should, in lieu of the standard library. So I thought I would probably know most of it, but I learned a lot through the experience too. Just like little details about like case folding in Unicode and like all these little things you wouldn't expect, even from just the first two, like introductory, the IO and the bytes and the strings packages,
right,
which seem like the most simple ones, obviously.
I think that's the interesting thing about producing content, right? So if you prepare a talk or an article or write books or do instructional videos, you always want to make sure that you don't misspeak. So you end up doing a lot more research, even on topics you think you already know well.
Mm-hmm.
And then it kind of forces you to learn new things.
Yeah, and I feel like it kind of lets you know really how much you don't know about the subject. And it helps you grow.
I really love the level of depth in these articles. It's fantastic. I don't think I've read better blog posts. I can't talk today. We need to start this whole episode over with better lips. So I really love the depth of knowledge in these, and it's not written at such a level that it makes me feel like an idiot. It's just the tone and the technical detail is perfect. I really enjoy these series.
Oh, thank you.
And we'll link to all of these in the show notes, but we'll start dropping them in the GoTime FM channel on Slack for anybody who's listening now and wants to kind of look through these posts if they haven't seen them already.
And this is so timeless. It's going to be useful for probably forever. We just need to do a good job in resurfacing these posts once in a while.
Yeah, the nice thing about the standard library stuff is it doesn't really change. They'll fix bugs and make it faster, but you don't have to go back and like revamp it on, maybe version 2 if that ever comes out for Go. But
never.
Yeah, if I agree.
I think we need more content going through the standard library like that and showing use cases and stuff, because you can kind of browse through Go docs and stuff like that and look on the Go website and look through these things, but that doesn't necessarily show you. And we talked about the source graph tool, right? When you start to use something, being able to kind of see example use cases of these things. So like one example is, I think Bill Kennedy had posted something about reading byte streams and stuff like that. And this was just a couple of days ago. And then you've also got your post that was recent about using kind of like all the IO readers and writers and T readers and multi-writers and stuff like that. And that drives that stuff home, right? It starts making people aware of these functions and packages that you might not have already been aware of.
Yeah, for sure. I think that especially, you look at these packages and like you see the layout, this alphabetical order, which is great if you know what you're looking for. But it's it's been fun to kind of break them down and kind of understand how the there's like subcategories within these packages and what those look like. I think it helps to make it more relatable.
I like the subcontext that comes out, not directly, but indirectly. I walk away reinforcing the idea of very small interfaces in Go.
Mm-hmm.
I know that, in a practical way, a lot of us think of interfaces as a big thing. I've got an interface to save my user to the database, but that's not really the idiomatic Go interface. The idiomatic Go interface is an IO writer. It's a tiny thing. It does one thing. And walking through these blog posts, really, it sort of, in the background, hammered that home for me.
Yeah, especially the standard package layout post. I was looking through that, and like each kind of approach was kind of like the negative sides of it. I could think of packages or projects that I've seen that like used it a lot. And you're like, yeah. And I've had some of the circular dependency issues and stuff like that based on kind of doing like Rails style layouts and things.
Yeah, and I think that I try to think about as well, like the Go standard library is it always just makes so much sense, like all the names and all the packages, and like it's just so well laid out. I think that was, big inspiration too of like, what did they get right, and how do we apply that to more, to more specific application development? So I think they are different worlds, but there's a lot you can borrow from both.
Mm-hmm. I think we need like a service, like library organization as a service. Here's my project. You tell me how to lay it out.
That's exactly the name of the talk, the conference talk that I think this should be derived from the standard package layout blog post. Packages as a service.
Nice.
Be like a package layout factory. You just generate.
Send your project to Ben and have him send you back what the layout should be.
That's fabulous. $50 and he'll reorganize all of your packages for you.
Look at him undercutting your price already.
Well, Ben's a superhero. It's only going to take him 10 minutes. That's a pretty good markup.
That's true. If he could do one every 10 minutes, that'd be a pretty good hourly rate.
Yeah, I mean, I've gotten actually, a handful of people so far on the Slack channel just pinging me, asking me questions about their design stuff, which has been nice. You just give some people some quick feedback, and it's nice to do that early on because this projects go on for years, and getting that first piece can just make everything else so much easier.
Mm-hmm. Yeah, it gets really hard, right? Like there's the common expression, it's hard to change the wheels on a moving bus. So especially the bigger projects, you start kind of going down this road and then you're kind of trapped in it. It takes too much effort to change out the organization and abstract things out the proper way. It becomes this massive effort. And so, yeah, getting off on the right foot is good.
Mm-hmm. I really liked when I saw Ben gave a lightning talk at GopherCon, and I was there and I saw it. I was like, okay, this is what I'm talking about. I need to learn how to do this, because a lot of the Go projects that I've seen, a lot of them has a model package, and I just cringe. I don't know why I cringe. I started to understand why now after going through this learning. And then I look at the models, and they have model information, and then they have database implementation information all together. And I don't like that. So I really, really like the way that Ben lays everything out and separates everything. And I just recently I laid out a project from scratch. And I'm not super experienced with Go, but I sat and thought about it for a long time, because I feel that I need to have things organized. And if I don't know where to put them, I don't know what it is that I'm doing, and I need to figure it out. It's just part of the process for me.
So that leads me to an interesting question that I always struggle with in Go packages. How big is a package? How big should a package be? And where are the boundaries for your packages? I always make too many packages. I don't know whether that's Ruby or Java in my background coming out, but I always make too many and then regret it instantly.
Yeah, I think I've gone back and forth. I used to be like very much on like the mono package, where it's just like put everything in there. It's a pain to try to separate out everything. And I've gone on the opposite end too. I don't know. I don't think that code size, like the number of lines, is necessarily a good proxy for it. Sometimes, you can have like a huge package and it feels fine. Other times it's rough. I don't know. I mean separating by dependencies has worked for me so far. And I think that it works up to a mid-sized project probably. If you have a really huge project, you might need to start breaking some stuff down further. But yeah, I've been everywhere on that spectrum.
Yeah, that was kind of the anti-case I was thinking of. When you think of a large Go project like Docker or Kubernetes, I wouldn't even know where to begin to start making those boundaries. It's so complex. When you think about dependencies, good Lord, what are the dependencies in Kubernetes? I don't know. Maybe that's just too deep for me to think about right now.
But I think you can go back to the basics a little bit too, right? So two common books that like I remember recommending to people over the years is Robert Martin's Clean Code, and he wrote another one too, um, and The Pragmatic Programmer from Journeyman to Master. And both of them, I mean, they advocate kind of you want things that aren't highly coupled together for one, but your packages should be cohesive, right? So everything within the package should make sense. You know, they should all be operating on the same data. And if two packages seem to want to know too much about each other, then really you probably have your code in the wrong place, right?
Yeah, that's a good point.
That's what Nathan Youngman says on our Slack channel. A package for a single idea is something he heard from a talk a little bit ago. And that's good advice if you can well define what an idea is. If an idea is something not very broadly defined, that might work.
So talk to us a little bit about the motivation behind the series of posts. Is this something you're going to continue doing? And this is kind of like a sidestep from some of the things you've been talking about, right? So like the first two GopherCons, the first one was like writing high performance databases, and the second one was static code analysis. And now it's kind of like a shift into like getting back to the basics, like, project organization and, library usage and things.
Yeah, I think that I go from low level to high level back again. And I think that this structuring of projects and these kind of like higher level concepts they're kind of where I'm at now. I've been doing a lot more on the application level and trying to figure out how that looks for Go applications. One thing that's always bothered me is when people say you can't write like websites and web applications in Go. Like that's always like it's an API thing, but it's not. You can't really build real web apps with it. And I think that there's not that sense of how you structure projects. So I want to find a better way to do that. Part of that's been from doing stuff with Bolt. My opinion, and at least in the our industry, is that we have containers and we have these like we have Kubernetes, and which are great tools if you're at that scale and you need the super high uptime and crazy requirements. But I think for probably 90% of applications out there, you could probably run on a single server fine, and handle hundreds or thousands of requests per second, which is probably most people's load, using something like Bolt or some other key value database. And I'm trying to figure out how to simplify the stack and get away from traditional SQL databases and things like that.
Yeah, there is a lot of the whole fear of missing out thing.
Yeah,
all these new technologies come out, and you want to feel like you need to use it.
Yeah, totally.
Otherwise, you feel like you're obsolete. You're not sticking with modern times. But as you said, like the majority of people's systems just don't need to scale, right? Like everybody doesn't have Kubernetes level problems, right? If you have just 3 nodes that you're managing, I'd argue like you probably don't need Kubernetes for that, right? It's pretty simple to do with Puppet and Ansible and things like this. You're just not, and they come with their own problems too, right? Like I love Kubernetes, I really do, but it comes with its own set of unique problems and constraints, and more things you need to manage and set up and configure and all these things. That it's just a lot of cognitive load, for something that you may not need. You're just using it for the sake of being able to say that you use it.
Yeah, no, I totally agree.
Going back to something that Ben said, what do you think or tell people when they say, well, Go is not really for web apps? Or I don't know if you said even for API, you hear people say that?
I think it does well with APIs. I think I did a talk over at GopherCon for the kickoff party that was around, a lot of the industry is moving. We're not doing, two things that, Go is not very good at is templating and SQL databases. They're not I mean, it's not great. You can use it, but it's not great. And the kind of the premise was, a lot of people are moving away from SQL databases, key value stores, or NoSQL, databases. So that's less of a problem. And then we're using things like React on the front end, and that's making it so we are interacting with APIs, and we don't have to have this templating side. So I think the industry shift is actually moving more towards something that's better, that goes better for.
Yeah, and even Amber, I learned that actually just yesterday. They have something that generates if they consuming a JSON API spec, like JSON in the JSON API spec, and you have a schema for that. I think they auto-generate codes. Somebody was saying it's super easy, and we can do that with an API in Go, of course. Now I have to follow up on something else you said. Now, why is Go not a good tool to use with SQL? I never heard that before.
If you use something like I came from Rails before Go, or that was my most recent language I was doing before Go.
You're in good company. We're all ex Ruby and Rails people.
Yeah.
Yeah, and I mean, when you're doing simple web apps that don't need a lot of performance, Rails is pretty great. I mean, you just throw some migrations up there, and you just start typing, and you get all kinds of stuff for free, and you're never really interacting with SQL at that low level. Go has some ORM tools. I haven't used any for quite a while. I mean, it's a lot of, I guess I'm not a huge fan of SQL databases. And I used to be an Oracle DBA for years when I first started out. So I thought, I think SQL databases are really cool for certain applications. But the more I get into it, there's just kind of this insanity of like how we're sticking data in and out and converting it and doing this like relational object impedance thing where the things that we do in our application don't fit in a SQL database. We have to break it out, and then when we create, we have to rebuild it back again. And going through the whole idea of sending these strings over to a database, they have to get parsed, and they get optimized, and then they get saved in query cache, and then they get planned, and all this stuff. Like there's so many crazy steps involved in using SQL. That's just it's like an everyday thing now. But if you really dive into it and think about it, it's kind of nuts what we do to be able to stick data into SQL databases instead of say, like I'm not going to say an object database, but even just or like in the instance of Bolt, serializing objects into bytes and saving those is really relatively well understood and easy thing to do. I'm surprised that our industry hasn't done that more of just going for these very simple tools.
So I need to find the YouTube talk that I saw, and I may be misspeaking about what he worked on, but I believe that he worked on like DB2 or something along those lines. And he was doing a talk basically about the things he knows for certain, which is like history repeats itself and stuff. And he was kind of bringing up like this whole shift towards key value stores, right? Like everybody's on the hype of key value stores, and he's like, that's what databases were when they first came out, 60s. Right? Yeah, like it was built into the mainframe application and everything. Like that's just what it did. And then they had these maintenance windows where they would update. And then they needed to try to avoid that as the internet came to be and these systems needed to be online more. They couldn't withstand being down, right? At first they were bank systems and it was okay for them to be offline after hours. And then so SQL kind of came to light because then SQL was sellable to business people, right? Like you could teach the basics of SQL to a business person fairly quickly, before you get into kind of complex joins and indexes and all that stuff. But just somebody wanting to just kind of query spreadsheet-ish data, right? Like they could do that. And that was kind of the shift there. And then he was talking about kind of like distributed databases. And he's like, yeah, we had those too, except they were called federated, and it's just kind of, history repeating itself. So now that we need performance, we're kind of going back the other direction, but it's just the new old stuff, right?
Yeah, for sure. And if you look at even SQL databases, I mean, SQL is really just an abstraction layer. Underneath, they're running, whatever kind of engine underneath, which is essentially just a key value store from like a row ID to some, byte encoded row that's in there. So it's interesting just to look at all the little layers.
And the difficulty there with performance becomes because of that layer of abstraction, it has to seek so much data off of disk to bring it up into the layer that starts doing the filtering,
Mm-hmm.
So like I know MySQL especially kind of overfetches data. Um, I mean, at least that's done on the machine level, right? It's not all being passed back. But
Yeah.
there's I like the approach that we're starting to think about things differently. Like I like the idea of column-oriented databases and things like Cassandra was a big one that I kind of liked. You could have like these just really wide rows, and you could scan along them and read in just as much of that as you wanted. And it kind of takes a new way of thinking about the problem. But these things are highly interesting, and most people aren't doing a lot of complex stuff with data too. That they can't just write their own little key value logic over the top of.
But I have to say that if you have used a NoSQL database and you have experience, then you can make trade-off calculations. It's great. But if you don't have that much of experience and you want to know, okay, I have this data model. Is there a way, should I be looking at a NoSQL scheme, or not a schema, but like a style or architecture? It's really hard to figure that out because you search on the internet, right? Where else would you go? And there are all kinds of opinions in each and every way, and you just can't make up a decision. So without going through the experience, it's really hard to learn how to decide, okay, can I safely go in this direction? Now, maybe I missed something. So if you know, how does somebody decide to do, okay, I can safely go with NoSQL here and I'll be fine down the road.
I think NoSQL is also an abstraction, right? So underneath NoSQL is interacting with a key value store too, right? So it's just trying to use some sort of probabilistic algorithms to figure out like where it needs to go to find the data. So I think that's an abstraction too. And choosing databases is hard. You really have to look at your data model and your access patterns, right? So, if you're looking stuff up by key a lot, I mean, having the overhead of, a SQL database just doesn't make sense, right? But there's also speed of development. Everything's a trade-off. So if you're doing a lot of stuff that's doing aggregates, right? You're trying to do averages and counts and all this stuff. This is going to cause you to have to seek a lot of data and read through it and perform those calculations yourself. And if you're comfortable with the trade-off of time for development for performance, that may make sense. But if you're trying to get a prototype out, it may not make the best sense. And I'd love to hear your take on it too, Ben.
Yeah, and I think that the difference of like NoSQL versus SQL, and I think the NoSQL isn't necessarily key value. It's really more. There's been a lot of databases that try to optimize for a certain domain, I guess. So like, and that tends to be where they shine. So if you have a database around, say, time series data, like you can really optimize big things with time series if you have a database specific for that, or if you have like a search database. These certain kind of domains that are more specific than the generic SQL. So I think that tends to be where it shines. As far as the aggregates and yeah, I mean, I think that if you're trying to get a prototype out and you know SQL really well, I would totally go for SQL, just without a doubt. It's probably not worth learning a whole new language or system to make something quick and simple. I think the things that I like about specifically key value is that there's a lot of features that you think of that tend to be more around SQL databases, where it's like, oh, well, you have a schema. Well, a schema and a key value store can be just a serialization library. So like protobufs is actually a great serialization library. And they give you things like versioning. They give you things like just really quick reading or encoding and decoding. And you layer that on top of a key value store, and you're kind of starting to build your own database. I mean, it's simple, but that's a good thing. And another thing is like when you think about SQL and the SQL language, I've done SQL for years, and I still find it to be really frustrating when you get down to like really more complex queries. Your language, your query language, when you're actually using like a key value store, ends up being Go, which is awesome because you can do anything you want in Go. So if you need to scan a table or scan a set of keys and values, or you can make an index inside of a key value store, you can do all those things, and it's really just Go code underneath that's processing it. So you can do a lot to optimize You no longer have these ideas of like query planning. Your query planning is done at, before compile time. You're writing the code to actually do the query.
There's little misses too with people with even indexing, right? Like the number of people that are surprised to find out that a single query only uses one index, right?
Oh
I
yeah.
think if they index two fields and they're searching on both fields, that somehow it does some sort of merge of those indexes and makes things faster. And that's just, it's going to pick the best one and it could be wrong, right? It
Oh
could pick,
yeah. Or depending on how you actually order the fields of the index, it may or may not use it based on statistics, and those statistics can change over time, which can change your query plan. And there's a lot of unknowns and just again crazy stuff that happens inside of a SQL database. I think we've become accustomed to that. I think are just much more simpler once you move to a simpler store.
the hard part, I think, about the shift becomes when you're not 100% sure what you're going to do with your data, right?
Mm-hmm.
It becomes very easy to open up, a CLI app or your favorite GUI app for a SQL database and just poke around at the data, right? And start trying queries and kind of discover what it is that you're trying to do and then implement that in the code side. It becomes harder to do that. But I think the biggest difficulty from the development standpoint, and Brian can agree too, because we've looked at a multitude of databases, it becomes the operational aspects, right?
Mm-hmm.
So I could agree that a key value store is fantastic for my use case, but it becomes hard because how do I manage backups and restores and things like that? There needs to be kind of like the operational pieces of it too if you're going to stand it up in production.
Yeah.
And along with the overhead of building your own code to interact with the key value store, you now need to build your own tooling for managing the database and fixing corrupted files and just all the stuff that goes along with it.
Yeah. And no, I totally agree with that. I think there's a lot of education side too that's missing. That if you're going to start out in that world, there's just not much there to really fall back on or like to learn from. I hope that improves. I mean, I'm definitely going to be writing some blog posts on that too.
That's a call to action for you too, Brian.
Exactly. Yeah. So I have a question for you, Ben. This is kind of out there question. Usually when you have a project, you kind of get a feel for how people are using it. What is the craziest thing that you've seen done with BoltDB?
I would definitely say this is easy. I can answer that right away. At the GopherCon, I was talking to Marty Scooch. I don't know if that's how you pronounce his last name. He does Blevy, which I thought was always called Believe. But Blevy is that full text search and go.
Yep.
He actually wrote an LSM tree with Bolt. Like it was multiple bolts that were merged together at runtime. And as far as key value stores go, they tend to be either LSM trees, which are kind of like these like level DB or RocksDB. They end up having these different levels of your data storage, and they kind of get merged at query time, and they get compacted and all kinds of stuff. And they tend to be much more complicated. And there's B plus trees, which is like Bolt. They tend to be very simple databases. And so he actually used the B plus tree Bolt to actually build out an LSM tree that would merge. And I thought that was nuts.
So how does that work? Is each level a Bolt database?
Yeah.
Wow.
Just cool, yeah. But he made it work. And he actually got performance improvement for I think it was write performance he was doing. I don't remember the details, but he has a lightning talk. That was great.
Well, I mean, LSM trees are very efficient on writes, and that's why you see stuff like RocksDB and stuff. They're very highly optimized for the write speed.
Oh, sure.
I'm interested. Like, did he implement the Bloom filters and stuff like that to determine?
I don't know if he got that far, but that'd be pretty cool.
Yeah, I want to see that. If you have a link to that, I'd be really interested in that because that type of stuff really interests me. And I mean, we'd have like a whole week of episodes on like how B trees work and LSM trees and all that stuff. But when we say LSM, for anybody who's not aware, log structured merge tree, and it's just kind of that access pattern, how it builds levels as it stores and kind of, as Ben said, kind of merges them back together. Cassandra is also another big user of LSM trees.
Yeah, and they work great for a lot of use cases. They tend to be much more complex, especially operationally. But they get much better write speed than something like a B plus tree typically for random writes. You do suffer in things like range scans. You need to go over like an ordered set of keys. They're typically much slower because they have to jump around and they at the different levels. But really good. It's just trade-offs. It's really all it is.
So now the largest user of Bolt is InfluxDB, right?
No, no. Influx ended up they have their own format for time series that's more efficient. The Bolt piece is more of a stopgap, just something. There are a lot of pieces going on as far as distribution of the data and query language and all that. We moved off of Bolt from as actual main storage. We have something called TSM1 now.
Okay. Okay. Yeah, I remember it having swappable backends to begin with, and I think you guys kind of decided, that was too much overhead to support all of them.
Yeah, at the time there weren't many people, so it was just way too much overhead. And there was some issues with some of the other libraries who were using more from an operational standpoint, not so much from a performance standpoint. As far as the largest user, which I'm not sure. Actually, I don't know how much is public around certain companies using it. I did find out there's one company that uses it. I think they have like a 3 or 4 terabyte Bolt database. And then I posted that on the Gopher Slack inside the Bolt channel. I said, "Hey, this is crazy. Someone's using it. It's 3 or 4 terabyte Bolt database." And there were a bunch of people that chimed in. They're all like, "Oh yeah, I got that too." And they're using these substantial sized databases, and it's working well for them.
Wow. So how does one operate? How does an operator manage a large BoltDB database that big? How do you take backups of that file? What are the operational concerns when it comes to using BoltDB?
So it is a B plus tree. So as it gets larger, depending on how you structure your buckets inside, the accesses will get. I think it's login slower. Don't quote me on that. One of those ON or big O notations, and so it will start getting a little slower over time. But as far as operationally, Bolt, the actual transaction itself is it implements IO writer to, so you can actually just send a writer to it, and it'll write out the whole database for you. So I like hooking it up to like HTTP. So if I just want to do a curl command, I can just pull down the database. Obviously not a public endpoint, but it makes it really easy just to take snapshots.
Oh, nice.
Yeah, it's fully serializable, ACID, all that jazz.
That's beautiful.
Yeah, and again, that's another trade-off too. If you're using an LSM tree, it's much more difficult to actually snapshot the whole database because you have multiple files, and there's a lot of other operational issues there. So it's not good or bad. It's just, again, trade-offs.
Yeah, I think that's with almost every tech decision, right? It's you kind of really have to look at your problem space and determine which decisions give you the most amount of benefit for the least amount of drawbacks, right?
Yeah, totally.
And I think that's kind of the whole thing, like how we were talking about the appeal of things like Rails, right? Like if you're a company that's bootstrapping yourself and you're trying to get a product to market and get a proof of concept up, I mean, there's a huge appeal in how fast you can deploy a proof of concept website in Rails.
Oh, sure. Yeah.
Especially if the majority of it is just CRUD based operations, right? I mean, you can throw together a decent site in a weekend, just, hammering it out.
It's pretty much what hackathons are. Or like the startup weekends. I feel like it's just like quick Rails apps in a day or two. You can really get some great stuff, initial concepts going.
What were those called? The Rails events, Brian? They held a couple here locally too, where they kind of did it across the country and people got together and they formed teams and kind of built stuff. It wasn't a hackathon. They called it something else.
I know what you're talking. It was like Gopher Gala. I did it once. Rails Rumble.
Rails Rumble. That's what I'm talking about. Yeah. Like there were some cool things that came out of that like I really wish like had gone somewhere. And then some of them were just completely humorous. And you're like, who came up with this idea? And it actually reminds me too, because there's a new database I saw come out too, called NOMS, and it reminds me of a Rails Rumble project that was here local in Tampa that was called the Nominator.
Nominator, that's right. I remember that.
I can't remember exactly what it did, but it was something along the lines of finding like local restaurants. But I love the name.
Yeah, like a food truck search engine or something silly like that.
Yeah, for the life of me, I can't remember. I haven't seen a Rails Rumble, but I mean, I haven't been completely connected to the Rails world in a while either.
No comment.
So Adam Stakoviak from Changelog just posted a link to it. the site is not up, but the GitHub still exists for Omnominator.
I want to make sure we get Ben to answer the question that Eric asked.
Answer the question, Ben.
Now that you've written a couple really thorough blog posts on, doing the walkthrough with Go standard libraries, are you up to doing more of it?
Oh yeah, I have 27 more posts lined up.
Oh.
I'm working on, and I'm trying to go up. I'm trying to start at the lowest level of the stack, which is why I did IO and bytes first, because they really don't depend on much. I mean, outside of like Unicode stuff. But I want to kind of move up into the encoding ones, and then things that layer on top of that, and so on and so forth.
Nice.
Yeah, the next one that's coming is the encoding package, which if most people have never actually looked at the encoding package. There's only 4 interfaces, but I started actually breaking it out and going to do some overviews of the other packages inside of there and what encoding means. And it's shaping up pretty well.
No, I think working with bytes and streams in the IO package is a really good place to start because, I mean, especially if people come from dynamic languages, they're highly used to just kind of working with strings.
Mm-hmm.
So they're going to favor those a lot and, create a lot of copies, and they're going to buffer a lot of stuff into memory when they don't need to, when it can kind of be copied across these, pairing together reader and writer interfaces and stuff. So I think that it's a fantastic place to start and to get people kind of thinking about problems in a new way rather than just I read in all this data from someplace, hold it in memory, and then write it out somewhere else.
Yeah, thanks.
I'd like to see your answer to Bill's challenge. It wasn't really a challenge, but it was his answer. He was looking for kind of a better way to do basically replacing a string in a stream, in a continuous stream. And I started on a solution for it, but I just haven't had the time to put into doing it. But I think that's,
replacing a string. What was the example?
Yeah, it was basically, he had a piece of code that he had put up on the playground. And it was basically just taking bytes. And then when it saw bytes in the stream, it would do it. And I was trying to do a continuous stream. So basically, no matter how many bytes were read in, it could figure out and kind of buffer just enough bytes for a second to see whether the next character matched if it only got a partial read.
Oh, sure. Yeah.
Because that's a common mistake people get when they're using readers and things like that, is to think that they're reading all the content in one read, right? It could come up short for whatever reason. So that was basically what I was trying to implement a solution for, to kind of demonstrate was, if you're looking for the word omnom, right?
All the time. Yeah.
Yeah. I mean, you could get the O and the M in at the end of your first read, and the rest is into the next. So you can't really look at just the buffer that came out of that. You kind of have to look at the stream and kind of build like a little state machine internally as the bytes go by to figure out whether you've found what it is. So
yeah, I was gonna say state machine. It's probably a good way to go.
So I started on an approach and I just didn't have the time to finish it, but I think it'd be an interesting thing to finish because it demonstrates a lot of the points from both kind of your bytes walkthrough and the IO package.
Oh, sure, yeah.
What was nice about that specifically is that it kind of turned into Vim Golf, where we started with an implementation and then somebody improved it, and then somebody else improved it, and then somebody really improved it. And that's how I learn. That's wonderful. I love seeing the evolution of performance, knowing that the first way worked just fine. Often that's where a lot of us stop because that's all we need. But when those cases come along where you really need that last bit of performance, it's fun to see how to get there.
So the interesting thing about that problem was I was like, oh, this is going to be easy. I'll build a little state machine. And what prevented me from finishing it is there's several little edge cases that come as a part of it. Like when you get like the partial read. So you need to buffer for a second because you can't stream it out the other side yet because you don't know whether you need to do the replacement yet, right? Like you have the first 2 letters. This could be the word, but it might not be, right? So you need like a small buffer, but only in that instance. You don't want to buffer when you're reading characters that couldn't possibly be part of the string that you're trying to replace. So, I mean, there's just overhead in doing the buffering. So I was trying to build like the most efficient version I could. And then I kept ending up in these edge cases where, based on the number of bytes that ended up being read, it'd be like, sometimes it worked. And I'm like, why? So programming is hard.
It is. Computers are hard.
So I think we got like 10 or 15 minutes left. Did you guys want to talk about anything else going on in the community and interesting projects? And I know I kind of mentioned that NOMS database. I don't know whether you've got a chance to look at that.
No, I haven't yet. Is that the one based on Git, or was that?
Yeah. That's
okay.
exactly
No, I haven't taken a look yet.
So I haven't played with it yet, but I thought it was pretty interesting because one of the things that appealed to me was, I mean, it has the content addressable thing, which is becoming popular too in storage, and the append only, so you kind of get versioning. But one of the things that I really want to play with the idea of is I love the decentralized nature of it, where, and this is like especially true because we can build client-side applications in Go, right? I mean, we're still working on GUI, right? But you can build client-side applications. So I love the decentralized nature of that. You could be working on something and it could merge with work that somebody else has done. So
that gives me nightmares thinking about a database rebase. I am not rebasing my database.
So that becomes the question, right? I have not played with it. So don't take that as me advocating you should go out and try and use this for that. But it did trigger that idea that I'd like to play with it and see how well that works. And
I'm curious to take a look at it. I didn't have time to read the README before we talked, but the trade-offs that they've chosen are interesting because in databases, everything is a trade-off you have to choose. So what's the use case that they're trying to solve?
Yeah, I was thinking that too. I wonder what their use case was.
We should wait, they have a Slack, they have a mailing list, and they have a Twitter. We should ask them.
Yeah. Oh, they do. They've got it all. And they even have a cute logo.
Yeah, typically we mention these things and then somebody who works on it or knows the person who works on it just happens to be in the Slack channel.
Yeah.
And then we're being fed information real time.
That's not happening today. Why are the NOMS people not in GoTime FM Slack? Somebody fix this.
Talking about cute logo, the project I want to mention today also has to do with database. And it totally won me just with the website, because the website and the logo is so also cute and well put together and simple and clean. So if you want to sell something to me, you know how to do it.
Give it a cute logo.
If it's cute and color coded, there we go. I'm sold.
I have this blade of grass, but it comes with a very cool logo.
Exactly.
Sold.
I'm easy like that. So I was looking. Oh, another thing. So this is not an ORM. It's just a productive data access layer for Go. And I'm finding this so funny because I think in every other language, people say, a package like this will say, we are an ORM. We are the best ORM, no matter how full functioned it was, full featured it was. But with Go, it's like, no, we're not an ORM. We're not an ORM. It's like,
it's a dirty word in Go.
It's a totally dirty word, right? It's so much. I chuckle every time. So I was looking at not ORMs and ORMs recently, and I found this today. It was actually in the Go newsletter, and I think I'm going to use it. It's not full featured, like it's not doing a whole lot of things that makes me scared. Being very new to Go, I think it's very new to Go. I don't think I can recognize enough to make decisions, and my package is doing way too many things. I back off. That's my measurement right now. But it does enough that, I want my SQL I want to have a little functionality. I have an API that's going to have filters and parameters. So I want to just drop them into variables and put them inside the function, and voila. I don't want to be writing out SQL and doing a bunch of things by hand. It's just, I think I'll gain a little velocity. So I think I'm going to use this.
That's where people in the programming world always differ. There's a category of people that want to write their SQL perfectly tuned by hand, execute it, and then map those back into structures and use them for whatever they need to. And then there's another category of people doesn't want to think about the database in any way, shape, or form. And there's very little in the middle.
Yeah.
So I'm actually somewhere in the middle.
Oh, you just had to be contrary.
With this, you can totally just send SQL. So I like that because I anticipate that I will need to do that. And if it didn't have that feature, I wouldn't use it. But I think all of these libraries will have that, I would imagine. So you get, something that you get both things.
So some of my pain points with doing straight SQL is, I mean, anybody who's tried to use just the standard database SQL package can kind of attest to this, is like scanning individual things gets painful, especially like when you're changing the SQL and you didn't get your type right and all these things like that can cause a lot of pain. So I like the idea of things that make it easy to map my data from my query back into my type. But there's also the other side of it. Like we talk about Rails. Like I love how easy Rails is to do these things, but there's two sides of that equation. And it's not saying that I don't believe in that, because I really do. Like that fast prototyping is awesome. But there's two issues I end up having occasionally with it is one, when you have a complex query, like typically you're fooling around with it, writing actual SQL, trying to make sure you get your data set right. And then you're translating it into active record type, format. And then you need to change it. And then you try to shift it back the other way. Right. So there's kind of like this translation process. But I mean, for the most part, I guess if you get familiar with active record, that's not a big thing. But for new people, there's also the fact that things like major ORMs can be leaky abstractions, right? So they're perfect abstractions when everything is going well. But if you don't understand the SQL that's being run under the covers, that can really affect your performance. You get into N1 queries, N+1 issues and stuff like that. Yeah, it gets hard. Like where is the perfect balance? And I don't know whether I have the answer for that. I feel like I'm somewhere in between.
Yeah, it is. There is the performance issue that if you're not aware what's going on behind the scenes, you can get into trouble. And there might also be the issue where you want to do something a little bit different, and now what? But you can always fall back to SQL, I guess.
And it sounded like from your standpoint, Ben, you like the ORM side of things. You think that that's kind of a point that we could be better at that would grow Go usage, adoption rather?
I wouldn't even necessarily say that. I mean, I think when you get into ORMs, unless you're generating the code, you lose. A lot of ORMs use a lot of interfaces, and you lose the type safety, and you just get a lot of issues on that side. And then I think there's some fundamental issues from mapping objects to relational ideas that you just can't get around. I mean, personally, I think you get around a lot of it if you use a local key value store. But again, that's not for everybody. I mean, you get away from N+1 queries that don't exist because you don't have to do fetches to a remote server. And you don't have like SQL injection because you don't have SQL. So I think it's a different mindset. So I wouldn't say ORMs are the way to go. Personally, I would avoid SQL if you can, but that's my own personal opinion.
All key value store all the way.
All the way.
So if you were going to avoid SQL, how would you build a system that had to have more than one active copy of the database? Is it possible to do something like that with Bolt?
More than one active copy, like are you just like distributing in the cluster?
Yeah.
I mean, I think you can do things around. I think you have the same trade-offs, whether it's Bolt or you have some other database. Where if you want to scale things horizontally, typically you need to shard your data. Like if you have a lot of coordination inside a distributed system, even a database, there's going to be locks and there's going to be all kinds of trade-offs there. So I'd say you could certainly shard out your data using Bolt. One thing Bolt is missing that I am working on is doing an async log or async transaction log. So you can actually connect one application instance to another and have it be
like a standby.
Yeah, like a standby. So I mean that's one alternative.
So does BoltDB offer any sort of replication log now, synchronous or asynchronous?
Not currently, but that is something I want to include in there.
Nice.
Because I think that would solve probably 95% of the use cases out there where a database and a standby you could fall over to. And that's what a lot of people run with Postgres. that uses async logs by default, I believe.
Right.
So I think we're starting to close down on time, and I want to make sure that we have time to go through Free Software Friday and stuff. But there's one other project you've been working on that I want to take time to mention, and that's the Secret Lives of Data.
Oh, sure. Yeah. So it's a project it has been active, although I haven't produced anything for quite some time. I did this visualization of Raft, and Raft is a distributed consensus protocol. And what that means is that if you have a cluster of nodes and they need to agree on some data, basically kind of really like a transaction log, you need to agree on all these things in this log. And even in the case of failover, or if your network gets split, how does that actually work? And it was made by a guy named Diego Ongaro out of Stanford, along with John Osterhout. I don't know if I'm not saying his name right. I totally butchered that. I'm sorry. But yeah, they've tried to make a simpler Paxos, if you want to think of it like that, or like a multi-Paxos. And but the problem is, it's when you read the paper, even probably several times, if you're not in that world of distributed systems, distributed consensus, a lot of these concepts just don't make any sense. So I used to do a lot of data visualization in a past life, and I really enjoy doing like D3 visualization. So I thought I'd try to apply that to Raft and distributed computing systems. So that's what the Secret Lives of Data is. It's kind of this visualization of how Raft works.
I love it because it makes the topics much more approachable, right? Like for a lot of people who don't work in the space, you say distributed consensus and their eyes immediately roll over, right? Like it's like this is something that's just completely unapproachable. It's only for, PhD candidates at MIT and, Berkeley or whatever. So looking at stuff like I've seen the Paxos white paper and stuff, and then you see Raft, and I remember seeing that, and the PDF's like 11 or 12 pages or something that explains Raft, and I was like, wow, this makes things much more approachable. And then I saw the Secret Lives of Data, and I was like, well, this makes it even easier to just kind of, it may not be enough to implement, but it's enough for people to kind of understand how distributed consensus works and things like that, and some of the problems along with it. And I saw on the GitHub that you had planned to talk about how Kafka works.
Yeah, that was my next one I was going to do. Also, just as far as seeing things, I feel like we have a lot of fancy words in our industry that typically mean really simple concepts. And I think when you can just see a concept, a lot of times it only takes 5 minutes just to visualize a concept, and you're like, oh, I totally understand how Kafka works or distributed consensus. Like there's scary words, but it's really simple concepts underneath.
Log structured merge.
Yeah, log structured merge tree. It sounds like a nightmare, but it's not overly complex when you get into it. The implementation is, but I mean the actual idea of it is not. So as far as Kafka, I started working on that, and I tried a lot of different methods for trying to visualize that. I want to try to do more of a blog post where it had visualization within it. That didn't quite fit. I wanted to move to where I was actually generating out video, because whenever you put up any kind of content on the internet, there's a whole bunch of people that tell you it sucks. And one problem that people said about Secret Lives of Data was it just moved too slow. So I think I was trying to figure it out where I could do video around that, and then actually give some kind of a narration at the same time, or some kind of a caption or something in there, just so it would move a little more at a better pace.
I think part of it too, if it didn't move faster, you could make it more interactive, which would force people to be slower, right? So if they were supplying the data that went across or something like that. But I think that's the hard part with teaching anybody anything, right? Is if you move faster for some people, it's going to be too fast. And if you go slower for some people, it's going to be too slow for others. And that middle ground is insanely hard to reach. And it's something, Brian and I know have struggled with. And anybody who's tried to teach anything to anybody, trying to find that middle ground, I think that you're going to end up leaving people off on one side or the other. And it's really hard, and it breaks your heart, trying to figure out a way to get everybody.
Mm-hmm. Yeah, I totally agree.
I mean, maybe you could have like an automated play thing where you don't have to click play. It just automatically kind of transitions at some set interval, and you could, put a slider for speeding it up or slowing it down or something like that.
Yeah, that's true. Yeah. Also, the other part of it was just insanely hard to make. because I actually had to implement, because it was doing it all the time. Like it wasn't a set amount of time. I actually had to build the wrapped implementation in JavaScript that actually runs behind the scenes. And so I'm trying to find a much more simple way to visualize.
I see. I didn't think about that. So you actually implemented Raft in JavaScript.
Yeah, it was terrible. It was a bad idea.
Brian is giving you evil eyes from behind the microphone. I know it. He's like, I know he's thinking somebody is going to use this for evil.
Yeah, it's going to be done. You never release that code, Ben.
Oh, no.
Never.
Ever.
Oh. Okay, so I know we're running short on time. I think we might actually be a couple minutes over. But one thing we like to do with each show is Free Software Friday, which all of us will kind of go across the board and list off some open source projects that are currently or have made our lives easier in the past. Just because, as we've spoken with other open source maintainers, most of the time you only see the hate. You don't really see the love. So we want to try to continue to spread love for projects that are making our lives easier. So with that, Brian, you want to go first?
Yeah, I'll kick it off with Minikube, github.com/kubernetes/minikube, KUBE. It's a really fast and easy way to get you going on a Kubernetes cluster on your local laptop, which is awesome if you don't want to run 17 VMs to have a cluster. Very nice, simple, lightweight, easy way to get going.
I can go next. First, let me mention that the library I was talking about is called UpperIODB.
Oh, the database library earlier?
Yeah, exactly. The not ORM library. Before I forget too, I want to mention that Ben did a remote meetup event and he showed how to use BoltDB. That was pretty awesome.
Oh, cool. Was that recorded?
It is, yes. So if you go to remotemeetup.golangbridge.org, you will have the past events and you'll find his event there. It was very good. I saw that one.
Oh, awesome.
The free software I want to mention today is called Stow. It's part of the, I don't know how to pronounce this, GNU. Yes. And I found this out through looking through Brian's and Eric's .files. I don't understand how I've been a programmer this long and I didn't know about this.
It's actually used under the covers for a lot of stuff to manage new versions of libraries.
I thought you only did symlinks.
It does do symlinks, so it can basically symlink your it can symlink the default version of, say, a dynamic library or static library to the most recent version of it that may exist somewhere else. But yeah, it's used for several things like that. But
it's very useful for .files.
Yeah, I cheated for .files.
Oh, I see. That's why the description here was a bit off from what I was expecting. But yeah, to manage .files, wow, it's so easy. It's so easy to use. Can't believe I didn't know about it. Now I use it to manage my symlinks.
Yeah, so the cool thing about it is you basically, it can layer symlinks. So the way I set it up in my .files is I have a .files GitHub repository, and all of my configuration files are stored in this .files directory, but then they're managed, the path structures based on the way they would be in my home directory. And then I can just do stow and give it one directory like git. And then it symlinks all my git.files to my home directory back to my .files directory. And then I can just keep adding files and keep telling it to restow for those symlinks. And if the directories already exist in your home directory, it symlinks individual files. If the directory doesn't exist, it symlinks the whole directory. And it's kind of cool because like if you have Linux and Mac and all these things, you can just kind of tell it to symlink just the things you need on that box rather than kind of getting all of your .files all or nothing. So
yeah, it's winning.
My biggest problem with symlinking manually was to remembering how to unsymlink things. And with Stow, you just like there's a delete command and so easy.
Yeah, to unstow it.
Yes, or unstow. I don't know. Don't remember. I only did it once. I set it up in super quickly and it worked, and I never had to look at it again. That's why I thought it was so great.
Stow-D, I think.
Yes. Awesome. So we got another lover of Stow.
Yay.
Yes. Thank you. And you did a great job explaining how it works, Eric. Thank you.
I set up that README a long time ago. And at the time, I think Brian was wanting to steal some dot files and a couple other people we worked with. So I wrote up a thing because I was having to like go to people's desks and help them. So it's just easier that way. So Ben, do you have a project you want to thank?
I don't really have a project. Mine was more like a maintainer. Kelsey Hightower. I just think he does, like, I know he's like the Kubernetes guy. And sadly, I actually don't use Kubernetes. But I think he does a fantastic job being an evangelist for that. But I think he's just like, he's done so much in the community, and a lot of stuff he's done just, personally has meant a lot to me. So I just want to say thanks to him. And I hope he keeps up, everything he's doing and supporting the community and everybody in it. And also, he had a fantastic intro at GopherCon this year. I thought he did an excellent job.
Amen.
So when videos come out, please go watch that.
Yeah, Kelsey is a person. Kelsey Hightower is a person, as well as his contributions in both, articles and sample code. I think we all can admire and kind of aspire to live up to that. It's just a great guy all around.
I want to be like Kelsey.
Me too. Can I be like Kelsey when I grow up?
It's going to take a lot of work.
So for my project, I'm actually going to sidestep development and Go projects.
What?
Yeah, I'm going to do it. So like as a hobby thing, I'm also like, in addition to being addicted to databases, I'm addicted to kind of information security. So there's a distro a lot of people use, which is called Kali Linux, which is kind of based on Debian, but I'm like an Arch user all the way around. So shortly before GopherCon, I stumbled upon this, and it's a project called ArchStrike. And it's archstrike.org. And it's basically like an Arch repository with like all the InfoSec tools that you might expect in Kali Linux, which is really cool. So now I get to stay in Arch and not have to have a Kali VM running somewhere. I'm not sure how many other people in the Go world are also InfoSec people, but I imagine they're there.
Both of them are very excited right now.
You have to be a Go person listening to this podcast who also likes InfoSec and ArchStrike and Arch Linux.
And none of them are in the Slack right now. I'm sorry.
So I think we made it all the way through our Free Software Friday. Before we start to close out the show, I do want to point out that the Changelog has another new podcast that's out that's called Request for Commits. And they're kind of speaking with people about open source sustainability and kind of the human side of code, kind of business licensing, how their projects are supported financially. And that is changelog.com/RFC. So definitely check that out if you like our podcast and the Changelog podcast, because who doesn't like the Changelog podcast?
Right?
There's going to be one guy. I know there is.
There's always one guy. Like the one guy on the GopherCon survey that thought Renee's talk was unsatisfactory. Seriously, a talk on the Gopher unsat? You're out. Don't come back. We don't need you.
Well, her talk was awesome, I thought.
I think it was a nice mind break, right? Like just kind of like you forget how overwhelming all that content being jammed into you for 2 days straight can be. So I think it was fun, and I think it was a nice step away from brain overload.
It was awesome.
Did anybody else have anything else they want to mention before we close out the show?
Oh, there's got to be something I forgot. Oh, I wanted to talk about, how much I love to generate things in DSLs. The quilt project I found yesterday, github.com/netsys/quilt. Pretty cool way to generate container orchestration for your container deployments. So it's a little bit outside of the realm of just straight Go programming, but it very much fits in my generate all the things mantra, which is a replacement for Docker Swarm or Kubernetes or Mesos. And it uses a declarative DSL to describe your deployment, and then you just run it. It's kind of cool.
Oh, that's interesting. I haven't seen that yet.
I find all the cool stuff.
All right. So I think we are out of time. I definitely want to thank everybody for being on the show. Thanks to Brian and Carlisa and Ben, especially Ben, for coming on the show and talking, I think, mostly databases. But this has been a great show. Thank you to all the listeners, both live and who will be listening. If you aren't subscribed, you can go to gotime.fm. Follow us on Twitter or twitter.com/GoTimeFM. And we have a GitHub, which is github.com/GoTimeFM/ping. If you want to suggest speakers or ask to be on or have questions you might want us to ask speakers. And I think that's it, everybody. Thanks again.
Thanks, Ben.
Thank you.
Thanks for having me.